Sure, yeah. Hi everyone. So I'm a geospatial developer. Just joined the Geovation not too long ago, about a month or so. And yeah, I'm here. I want to talk to you about R and R as a sort of statistical programming language, because I think it's kind of not too commonly heard of, but pretty useful for GIS and just sort of inspecting geospatial data. So um, First off, yeah, I just wanted to say, hey, this is me, geospatial enthusiast. I love maps. I like to make maps, digital. If you get a chance to print a map, then that's awesome as well. I've just joined as a developer, here to sort of support members and startups and get stuck in. And yeah, when I'm not working, I like to sort of be bimbling around the UK. In my camper van, and getting out in the sun, which is it's looking beautiful right now. So yeah, but let's get right into it. I want to talk to you today about what R is, and some background on R as a programming language, how you might get set up, because it's a pretty simple process, simple enough for one slide anyway, or a couple, and what R sort of geospatial R looks like. R may not be traditionally thought of being used for geospatial analysis, but it's got a huge support. So I sort of want to talk through that, and also, yeah, it'd be good to go through some data and hopefully get people wanting to get started. So without further ado, we've got So what is R? I mean, R is a multi-platform that can be used sort of on any OS. It's an open source language developed by the community for the community. It's also supported with its own environment. It's an IDE, so that's an integrated development environment. But traditionally, it's been thought of being sort of statistically focused, and we're thinking like research, science, academia. That's where I first approached it when I was at university, and but I think it's got some real legs and quite a lot of useful packages supporting it, and there's a ton of them. There's a ton of packages, and I'll highlight a few today when we go through some of sort of what I've got for show. Yeah, so I think it's best to start off thinking like what isn't R as well. R isn't a program. It's not like Word. It is a programming language. It's something you download, you install, and you can interpret in Unix or in the command line. It can be used like that or in an IDE, and yeah, I'll go further to talk about that. So it's supported by a project called the R Project, which is run by the R Foundation, a group of people sort of responsible for administrating how R develops, the directions R as a language takes, and how the community can access this. This little picture there is just really old school Mac layout. R's been around for quite a while, as you can tell with that screenshot, and it does a myriad of things. We're talking sort of data visualization, graphing, complex analysis, sort of spreadsheet view, and pipelines. And so the way you sort of go to access R is through the R network. It's sort of nicknamed CRAN, and you can go and download that. Your version from your sort of nearest mirror and a local site. And I've got links in the presentation, so afterwards you'll be able to sort of go and get started from this presentation, hopefully, if you need to, or if you want to. And yeah, so there's over 16,000 packages that support R. And packages you can think of like any sort of programming package. They're extensible, they add to the capability, and they make certain tasks easier, or they make them possible. And some really key ones for sort of data visualization and geospatial stuff. So why might you use R? I think people kind of think about programming languages, and there's a choice out there. You know, data analysis is nothing new now. In fact, it's pretty much core for many businesses. And I think the five main takeaways I think for R are these. It's both a programming language, it's sort of out of the box ready to help people communicate their data in an array of visualizations, and it allows you to explore data, just get data in quickly and run through it and have a look at what you're looking at, both as sort of an object, which we'll look at, and also as inspecting it through the console. And because of that, you can create really nice models, data models and pipelines where you can have repeatable processes for manipulating, analyzing, and outputting. And that's sort of where we get into the sort of the transformation part of R as a language. Yeah, so I think a lot of people ask, as I say, like there's a few things out there for data analysis. So a lot of people might be thinking, well, why is it any better than, you know, me sitting on Excel or something like that? And I think it's a good question. Excel, if you think about R versus Excel specifically, which is what I'm talking about here, the tools work in very different ways. Excel is sort of a button clicking process. It's got a good graphic user interface, depending on who you ask, and people recognize it. Maybe it's what's taught at schools as well when you first learn about data in general. And so it's one of the first things that comes to mind about how you even look at data. And so, yeah, Excel is really prevalent. Everyone uses it. It's proprietary, so it's not open source. It's not free from the point of use. So that's kind of a slight difference to our, well, a very big difference really. R is open source, and anyone can get started and interpret with data. And again, Excel has this familiar spreadsheet style to a data analysis, whereas R doesn't necessarily. R is a language. You can process, you can view, you can visualize in any way you want. There are some tools out there that kind of set a standard, and I'll go through some of those today about what I think a useful way of using the language is. What Excel isn't, and where R kind of picks up the mantle is data agnostic. The format of your data, there will be a package out there to read it, depending on what you're using. Some really obscure raster data, or even GeoJSON, you know, things you can't really throw into Excel easily. And that's really cool. And because of R being a language where you can write it as scripts, it fits really nicely into your standard version controlling, you know, so you can throw it into Git, you can store it on GitHub, you can see track changes and bits and pieces like that. I think where there's more of a sort of similarity is R versus Python. Python's a programming language. A lot of you probably recognize it and know of it. It's popular, it's open source, and it's used by developers and data scientists. I think there's an argument to say that Python can do everything that R can. But the difference here is R was specifically designed for research and statistics and analysis. And you kind of get the feel for that when you get into the language and start using it. It's got some really deep analysis options as soon as you get started, and they come as standard with your install. And then the package system is as simple as install, load. You don't have to worry about versions. It sort of sorts all that stuff out for you. And I don't think we could say the same for Python sometimes. And as I say, out of the box, R has visualization tools that start from being very basic, which I'll show, to getting quite complex into something that you can sort of proudly publish. And that's a really nice feature of the language that I'm going to show today. Yeah, interestingly, I think it's good to talk about setup. So I spoke earlier about actually downloading the language. You can go to the CRAN to download sort of the closest mirror to you, your language for R. I think the current version is version 4.x. I think it might be 4.2. And then go straight to RStudio. RStudio goes hand in hand with R. It's an IDE. It has sort of four main panes. You can load up your script that you're writing. You can view the console that you're executing. You can see the data that you're storing and the history that you're running in the top right over here. And then down in the bottom, you can see plots, whether they be interactive, what you're outputting at the time. They could even be documentation of how packages work. And so this is what I'm going to be running some of the demos in today. What's cool as well is RStudio has a sort of cloud element as well, which is pretty neat. There's a cloud solution out there where you can sign up, log on, and it's, you know, as is with Google Drive or anything cloud based, it's open to anyone you want it to be. You can pick it up, put it down, saves automatically, all the good stuff that comes with cloud solutions, and that's a really nice development. It's been around for longer than I realized when I sort of found out about it, and yeah, and I recommend having a look there if you don't want to sort of get something installed on your local machine. Cool. So now I'm going to sort of focus a bit on our sort of geospatially, some examples of visualizations, getting started with some code, loading data, bits and pieces like that. So we're going to go through some code snippets and yeah, some nice outputs. So yeah, geospatial data visualization examples. I've got a few there, and some of them are pretty awesome. Don't get me wrong. This can take some time and some skill to sort of focus on what you want to output. Some of them are very infographic-y, and that's great if that's what you're looking for. This one on the left is showing the frequency of cycle hire journeys, and the thicker the line, the more journeys are going on that street in central London. And then we've got some really interesting ones, just a spinning globe for the sake of a spinning globe, you know. That's the sort of power, a gift that can be outputted from R, just with the support of a few extra packages. And again, representing rasters in a more graphical way, with 3D, with ray shading and things like that. Or sort of the infographic style of showing your sort of GIS layers. I think they're all really useful ways of presenting geospatial data and getting people engaged, and also understanding what you're looking at or what you've been given. Cool. So I just wanted to run through some code really and sort of get stuck in. So R begins with running packages, getting what you need to support the analysis you're going to do, and you can access packages by going on what's called the tidyverse online and seeing what's out there. You can also look at R packages in general that aren't in the sort of tidyverse category, which is a selection for data analysis specifically, and see what's supporting. The ones we're going to focus on today are some of those tidyverse packages. Simple Features, which is the package to support geospatial data. There's been a few iterations of different packages if you used R before, but Simple Features seems to be the sort of current standard, and very simple to get up to scratch and read data and explore it. This next package here is really useful for manipulating data frames, and what I mean by that is getting stuck in, making changes, renaming columns, editing data on the fly, joining data, and I'll talk more about that as we get to it, because there is a bit of that in this run through. The last one, TMap, is a really fun little visualization package. Stands for thematic mapping, which any sort of mapping really, and it has a really nice plot and view feature where you can see something static and something interactive. So this is what you'd run in the command. It would run through a bunch of installs, and you'd see that happening in the console in RStudio. And then the library functions would load those after you've run them. So those two commands go sort of one after the other. Cool. Yeah, the second is exploring these packages. Once you've got packages in, some of them may have some really cool documentation you can look at and give you a bit more insight into what you're going to be using or the options you've got in front of you, because sometimes it's not quite too clear. I know I've stumbled across problems in some programming languages like Python where you can't quite work out what the documentation was saying, and you can't interact with your tool set in the command line to see exactly how extensible things are and what commands you can work with. So this is a neat feature if the documentation exists, and that's a big if, but for Simple Features it does, and this is the output you get actually. If you run the first sort of vignette line, that'll give you effectively a catalog, and the second, if you choose a section in that catalog, will run up a doc which you can scroll through and see, and that's super neat if the package has it. Yeah, so getting stuck into some data. So you've got a bunch of data. In this example, I'm working with local authority districts, which are bounding data for the UK, and that is in GeoJSON format. That is a spatial data format. And then I've got census data that has a common attribute with that local authority district, but it's separate. It's come from ONS, and it's the most recent census data for 2021. I'm looking specifically at population density, and those two are separate right now, and that's how they're going to be loaded in. An important thing to note is when you're loading data, if you can work out the working directory you're going to be in, you can set that up to begin with, and then your paths for bringing that data in is super simple. You're just sort of naming the file, because you've done all the legwork beforehand when you set where you're working. Another option is loading data from packages. So there's a few packages out there that have a bunch of data that you can just go and work with. You can get started on the fly, and I think that's pretty powerful because it means you can get up to speed and have a look at the possibilities that this sort of language and IDE might have for you without necessarily having data ready, which sometimes is the hardest part, is sorting through the data. So I'll show that. I'll show that as well. Right, so exploring data, there's a bunch of options once you've got data in, but some of the ones I really like are a summary. So a summary gives you effectively a statistical summary of the attributes of that data set. And that's not actually so useful for geospatial data because, well, at least this geospatial data, because the attribution that came with local authority districts was purely geographic and geographic information around that. So for instance, the minimum longitude that's in the data set or the mean longitude is not particularly interesting or groundbreaking. But more importantly, you can print those names and see exactly what your data set holds, what attributes have you got going on there, and what can you sort of start to leverage or maybe join to something else. And then you can whack up some plots straight away. That third command here, plot, will give you all of the attributes plotted next to each other, which in this case is about 9 attributes, and it all gets quite overwhelming. So I've pulled out a couple and shown them here, which is plotting the longitude variables left to right and the latitude variables, so bottom to top. So next, as I alluded to, like joining data is pretty important. So a data join in general can be thought of finding, 2 common attributes between the data sets and naming that, and then they'll link on that data set and extend the data set's attribution. So I like to think of that as we've got really good geospatial data that's coming in from the ONS, and we've got census data that's rich, not just, I pulled up population density for this example, but if you go online and check it out, there's quite a few options, but they don't come out of the box together. So I found a common attribute just by looking through this data pane here, which is where you can see your data once it's loaded. I've sort of looked through the attributions on the left here with the next to the dollar signs, and I could quite quickly see that LAD21CD links quite nicely to an area code in the census data, and so this command here does an inner join where it looks for matches on both sides and just gives you that data set. I think there's in many joins, it's important to understand whether you're missing anything or losing anything. You can you can see here actually on this join, I had 375 rows of data in the census data and 363 rows on the local authority districts. On the inner join, I end up with 331. So there's quite a few between that didn't actually match up, and that's because a lot of this census data was specifically for lower areas, whereas the local authority districts actually ranged, and some of them were for much larger areas and not. So in the end, the inner join worked out to give me sort of the best geospatial data set alongside population density, and that's what that command does. The arrow here is just assigning that to a variable so you can use it later, and that's what the arrows mean throughout. You can think of the command actually is not too dissimilar to something like SQL, where you're sort of naming the column that you're going to join on. And actually, if your 2 data sets have a common name already, a common column that's already obvious, so say the census population, the census data had a column called LAD21CD by chance, or actually in some cases, a good thing to think of is the OS as well, where we have UPRN that exists across data sets, some being geospatial, some not being geospatial. You could just say, I want to inner join that with that, or left join that with that, and it would just join because it would know that it has the sort of ability to just know that that's a common name in between them. It wasn't that easy with this one, unfortunately. And then I wanted to sort of wrangle this data and get it looking a bit better, because there were bits and pieces in there that didn't sit too right with me. LAD21NM in the geospatial data set is a silly name for for just the name, or it's a coded name, and when I want to do some analysis, I was thinking, right, I'm going to get that renamed. So I'm using this rename function here, and this operator is specific to that dplyr package that we used earlier, and it's just resetting that data set with better names into the data set and overwriting. That's why I'm sort of reassigning it over the top. So these are kind of overwrite assigns, just so I don't fill up that environment with loads of data, and that's sort of this pane here. I don't want to fill it up and get confused. So and then population density had some crazy output from the CSV, so rename that. And country was missing, had a capital, but all my other things were in lowercase, so thought I'd sort that out, as I'm a bit particular, maybe picky. And then I noticed actually some problems with the population density value after I'd renamed it. I tried to plot it straight away, and it wouldn't plot. No sort of thematic mapping or nice gradient was going on there like I'd expect with higher values and lower values. So I had a little look back. So I'm just going back a slide here, and I can see straight away, if you look at the old name here, that it's a character variable. So that's not going to work straight away. It needs to be numeric at least. And also, not only is it character, but it's full of little commas, which is a bit of a pain. So found some functions out there. These are actually base R functions that don't rely on any extra packages to be installed. Gsub, it means sort of global substitute, which you can think of as being a replace all, and it looks for any commas and it replaces them with, in this case, nothing. It removes them effectively, and you basically point it at the column or attribute that you want to do that on. And then as numeric, sort of it's what it says on the tin. It just turns out that data type from character or string to numeric there, and then sort of reassigning that back over the top of the column. So we override that column as now being numeric without commas. Neat, there we are. We sort of wrangled the data a bit. We got it sorted. We still had a bunch of extra columns there that I couldn't see a use of right now. I can go back and get them later, but I didn't see a use of right now for mapping. So I did a little subset where I overwrote the data again by selecting just the columns I want from LAD with population density for the UK, and I just picked out name of the local area districts, population density value, the country that sits in, because we're split across two countries here. If you'll notice, we've got England and we've got Wales, and the geometry, and then pop that into a plot straight out of R. That's not a special package again. This is just what a quick and dirty plot looks like. It's not necessarily how I would style it, but we'll look at that a bit later as well. And that ends up looking like this, which is quite a neat way just to get a plot up and running and see, what sort of relationships you've got going on geospatially. It gives you a nice little legend, just to see what's going on. Obviously, you can tell where people live, hey? And then I've also shown down here sort of what that data set looks like once it's been finished. And so this is the data set we've been working with, and I'll take subsets of that as we go through this sort of code run through that I'm doing now. But this is the main one. Cool. So I wanted to get a little bit closer. I wanted to see these color changes more. So I thought I'd pick a nice value to filter on. So I've got Welsh LAD with population density now. You can see how the names can sometimes grow if you're not very strict with your naming policy. It's not my strength, I must admit. So this is the new data set that I'm pulling out. I'm using the one we just saw, but I'm filtering it here on the country column against the string Wales. So I'm getting all the local area districts that are Welsh. I'm plotting those, as I say, as I sort of mentioned earlier. You get all of the attributes that are available plotted on a map next to each other. Because we've done a filtering, aside from the geometry attribute, there's only three, which is the country, all the same, Wales. So it's sort of done a good job. A population density, a name. And no, I don't think these names are actually the same. I just think R picked a color scheme, which coincidentally made some of these colors the same. So sorry if that's a little bit confusing. And you might want to take a step back, really. As I said, getting the statistics side of R is really important. And if you've got big data with lots of variables, lots of cool statistics to use on, you can do a bunch of cool stats on them that aren't necessarily geospatial. obviously we've got some min max there. I've got a max, which I'm then using to pull out what actual LAD that is with just the name of the max, and that's sort of how I'm doing it with this function here. And this console output is respective to the commands above. So Cardiff, unsurprisingly, has the highest population density in Wales, and then the mean population density across Wales is 441 people per kilometre. I think what's cool is if you had a large data set, there's quite an array of statistics you can pull on data. I previously used it to do clustering, geospatial clustering, and just statistical clustering. You can get some really nice statistical outputs in 3D graphs as well, which are interactive. They can spin around. It's the world's oyster really with a lot of this stuff. So it's worth sort of, if you've got a bunch of data and you're thinking about visualizing it, you can run it with just a few commands and get a nice output. So it's worth doing a bit of research if you think you've got that data to play with. And obviously geospatial operations, I wanted to show some of the capability that it's got. And naturally, some of these functions don't look dissimilar again to SQL if you're used to Postgres, a database language. First off, we pulled out just the local area districts that came with a few bits of data, population density. They came with name as well and country. But if I operate a union on them, I'm just going to get the geometries all merged together into one. So I'm just going to get Wales. And that can be pretty useful if you just want to get a good overview polygon. You want to get a polygon for selecting intersects with. It's quite a fun little function. And I've assigned that to Wales and I've plotted it. And what this plot's doing here is also having this reset false flag, which is saying, if I plot again, don't overwrite me, which can be quite useful when you're layering data, which as I'm doing here. So I'm using another spatial operation, st_buffer, I should say, which is looking at Welsh local area districts with population density. It's looking to find the geometry that has the highest, which is unsurprisingly Cardiff, as we showed earlier. It's going to throw a buffer around that of 5,000 meters or 5 kilometers. And then it's going to add it on top in the color red. And so we pulled out here just the basic geometry of Wales with a buffer polygon of Cardiff, which is pretty neat in just 3 lines, maybe with one sort of slightly nested command. Quite powerful. So I wanted to talk through maybe some better cartography. I said earlier that might not be quite how I would style it. And a really cool package that's out there is tmap, or thematic map, as I mentioned earlier. And it's got this plot mode and this view mode. And the plot mode is powerful. It's got a command called QTM, which is just quick thematic map. You tell it what simple feature data set to throw up, and it'll do it. This is the result of the first command here, the gray map. And then this one with a little bit more attribution and sort of layout options that I've added in will say, right, do this, make sure your fill is based on this column, and make sure the legend comes out with a title or something like that. And this is what it passed up, which is not a bad first attempt if you're just looking at the distribution of the density across Wales. But you can get a lot deeper, and there's quite a few attributes and commands and layout options here that I've had to play with to see if I can make something that I think looks quite good. And so yeah, first off, we've got the shape command where it's going, right, this is the data set that I want to show on a map. This is what I want to fill it by. The column I'm going to use is the density column. The title I'm going to give it, as before, is this. And then you can choose color palette. These color palettes are based on something called Color Brewer, which is worth throwing into a search engine, because Color Brewer is a website where you can make your own palettes. You can find the palettes that are out there, the options you have to you, and you can pick from them. So I quite liked purples to green with blue in between. You can also choose this categorization style and what sort of how you're going to break up your values. I find Jenks for the map I'm about to show showed the variation quite nicely. It didn't put things in bins that were too large, and you didn't sort of miss detail in places where there exists differentiation. You can set the borders of your geometries. I went for a nice light grey. You can set some of your map paraphernalia. You're talking like scale bar, compass. You can give those some cool stylings and make them set their position on the map pane. And then also, yeah, the layout's not too dissimilar. You're setting where the legend sits, its text size, and whether the map actually has that frame around it. So in this last map I showed, these all came out default with a frame, which I don't think is that necessary. So in the end, it ends up with this map on the left, that command, and that map on the left is quite neat. It's going from those purples to greens. It's showing the density and how it varies across Wales. It's got a nice north arrow. It's got a scale bar, and it's got a legend with a cool title. So I think it's good to just get something running and show some data. And then on top of that is the option to set tmap mode to view. And what that'll do is it'll take some of the styling that you sort of mentioned here when you're using R, and it'll pop it onto a slipping map. In this case, it's Leaflet. It's powered by Leaflet. It'll come straight in with a base map, which is quite neat. You can zoom in. It's interactive. And so what I'm going to do now is just I've sort of gone through the commands stage by stage. I'm going to get RStudio up, and we can go through running some of those things as well. I'll highlight the commands and I'll run them as I go, and hopefully that's useful, and we can look at it as we go. So this is what RStudio looks like. It's kind of what the screenshot I said and what it says on the tin. You can run these to begin with, and they'll install. You only have to run them once. So maybe I'll run one to begin with, just so you can see what that console looks like. So you're looking down here, the bottom left of the console output. I've highlighted this, and I'm just going to run it with that button there. So actually, that installed really quickly. So it pings to where the repository for that package is, and it goes and downloads it. So I've already installed all these packages in my R prior to this. So all I have to do is sort of activate them. So if I pick these all up, they're gonna activate just with that library command as I showed earlier. And then exploring, as I said, pretty cool. Click on that one, instantly pops up and moves you to where that catalog is. And then down here you're going to get a nice docs. Setting my working directory, just running that quickly, and it's you can set the file viewer down here as well as the plot viewer. It's just a sort of an interactive viewer space, and you can see what you're storing here. So I'm storing my R command, I'm storing the PowerPoint or PDF output as well, and the outputs that I'm able to produce from this code, this script, and the data that I'm sourcing. So interestingly, I've set my working directory of data here. So this script is now looking in this folder, and I can assign with a read command that variable, and they'll quickly pop up here like that. Cool. So one thing that I mentioned was you can also load data from packages, not just from files. And I just wanted to give a quick example of the availability of data that's out there. It's sort of on you to go and find out sort of all the data that SP data as a package offers. That's what this package is called. But there's a few here that I pulled out that look quite cool that we could quick throw up into a plot. So the first one's the world data set, which is pretty neat. Comes with 9 variables. Some of them are interesting. If you look into the data sets online, you can get the metadata for sort of the age of this data as well. You're sort of getting continents, getting population, life expectancy. It's good for just a quick data set, as I say, that's validated. There's no sort of polygon issues or anything like that. And you can run some analysis on it and do some quick mapping. There's also cycle hire data. There's no base map here, so it's kind of hard to tell where you're looking. But this is cycle hire points in central London, as taking it from OpenStreetMap as a data source. And this is mapping the River Seine and that's just showing the tributaries and the main river as well. So there's a range of data. You can also work with Raster data here, but specifically for this example, I focused on vector. So if we go back to the data sets that were focus, I showed these running. So I'm not sure they're too relevant, but the plot, just so you know, when you run it, it runs like I just showed before. plot pops up here. You can have a look. You can click there, and you can zoom and sort of take a look at the output. It is an image as well, so you can press export, save it as a PDF. You can get your maps out quite quickly, as well as running output commands or save commands in the script that I'm going to show later. So then I run the join to get my data set that's got population density with it. As I say, you can explore the data sets here and see those columns. It's quite neat. And then I'm running that organization I spoke of earlier. So I'm just going to run that all together just so I don't bore you too much. And that will have done the subset, done the renaming, and also done the sort of data changing here to take out those commas and turn that into like a nice numeric data type. And then I can run the plot like I said before and get up that initial map of London that we can start checking out. I'm just zooming in on the image there, by the way. It's not interactive. Can make that subset of Wales, and these are all popping up in my data catalog on the right there. I can plot Wales, see all the good Welsh stuff. Run your statistics; they come out down in the console, like I said. And then there were the spatial operations here, which if I run together, will give that nice output that we looked at earlier. Then we get on to making maps, and this does differ slightly from the presentation because I've sort of gone a little bit rogue, so I could show you some different things. So it's not just sort of parrot talk. So I'm going to set TMap into plot mode, which is quite neat. I want to get a quick thematic map, like I showed. Sure, that's going to pop up, just a grey map, nothing too fancy. But okay, say I want to do some quick styling on that thematic map. Yeah, it's got me. It's okay. It'll do that for me, and I can export that if it's good enough to just show some data to some colleagues or get something out. And then I'm just doing here the sort of nicely styled map that I spoke of. I run that, and it will assign it. It's assigned it there to an output map variable, just so I can use that and as an output later. So if I run that variable, it will know to throw that plot up and show it. So this is exactly that map that I showed at the end of the presentation there. What's quite cool is some people might be interested. Can I get a good base map here? And there's actually a nice package if I scroll back to the top there called map tiles, which you give it a cool source and it'll have a look at. It'll go and give you a source for those base maps. So it's running a command here called get tiles. You tell it the data set, so it knows the bounding box to go and get those tiles from. It'll get them as a raster. It's got a bunch of providers and documentation. I quite like Stamen's cartography, and I quite like the tone of light style. And depending on sort of how fine and how many tiles you need, you can set the zoom level for that, and it will crop it right down. So I run that. It takes a little second because it's going off downloading those tiles ready to be shown on the map, and then I can run this command. The only thing that's different here from those ones I ran through really is we've got this beginning bit that's going. I want to throw up the base map raster first. That's an RGB image, and I want to combine that with that other map data, and it's sort of building up layers. You can think of these as layers. We've got some map layers, we've got some layout layers, and we've got some cool raster layers. So if I run that now, it's just going to take a second, and it's a good attempt at showing a good base map. I've set the transparency down a bit on the overall layer so we can see what's going on underneath. We get some context here over just what we were seeing before. I'm sure you could take this further as well. You can put some nice boxes. You can expand the layout a bit more so it doesn't look as tight and constricted. And you can play around for as long as you like, really. And what I wanted to show as well, finally, is running the interactive map mode with TMap, which I think is pretty neat. So you literally do it by setting TMap mode to view, and then if I went back and ran this command with the raster and stuff, it would actually put that onto an interactive map because it takes the mode that you're setting at that time. So you do have to remember where you are in the order of things. But what I'm going to do, I'm going to put on the map without the base map because luckily for us, it shows a cool base map that you can pick through. And so here I can zoom in, and it's got all the good stuff that you'd expect from interactive maps. It's taking a little while to load. These are actually raster tiles, but the leaflet does support vector tiles if you've got a source for it. And it's sort of highlight or give you the names of those districts that we were showing before, and you can click on them and it'll give you the population density. It's not just for slipping around, it'll give you some interactivity as well, and it's got your legend up in the top right, and if you're bored of the grey canvas from Esri, you can pop up OpenStreetMap, although it's a little bit jarring with this color scheme, so I'm not sure I'd recommend it. Also, world topography, this actually looks quite nice, a bit of a calmer map. Yeah, neat. So that was that zoomed in. The very last thing I wanted to run through is outputting, and it's as simple as it sounds. There's a command called save. You pick the map you want to output. For me, it's that output map that I set near the beginning here, near the beginning of making maps. But it's the I'll just run it again so we can see it. It's just the plain map of Wales. And if I save literally just by changing the file name to the file extension to PNG, it's going to save as a static map. It knows to do that. So it's done that. And if I go into the file directory where it's stored, just in outputs here, I can see that here. Quick map, ready for download, good quality output. And you can add your the output size and the bits and pieces to make sure it's to the right. DPI output to the right, scale, size, bits and pieces like that. And then I can save as well the HTML document, which gives me that nice slippy map just ready in my file system, and you can also pick through that HTML and get the code and deploy it if you want to. It really is there and ready to use.
Sorry, Richard, cool. Can I just quickly jump in? Apologies for interrupting there. Yeah. I just thought this question is quite relevant just as you're demoing. Could you just touch on sort of what's a raster?
Oh, sure, yeah.
Back to that basic, yeah, thanks.
Yeah, sure. So, I mean, the difference between vector data and raster data is vector data is that exact point data. It's your geospatial data. It's those polygons which are effectively made up of points joined together, turned into polygons. And then raster data is a gridded data set. It's you can think of it as an image as a raster, just a picture you take on your phone, for instance. It's just really fine resolution square pixels with a color value, and the finer the resolution, the better the picture. But in terms of geospatial data, raster data can be full, and that's why I said actually the base map is raster data, because you can see if we set this to view here, just so I can do a demonstration, and we have the base map and we actually run the base map as a slippy map, you'll see it overlays it quite nicely. You can zoom in, and on that you'll see that this doesn't sort of improve as you zoom in. That's the best the raster resolution is there on that base map there. But you could also show here the raster of surface temperatures. You don't have to assign color per se to a raster. You can assign any kind of variable. It's actually a really common data set for remote sensing. So you could assign air pollution. You could assign climate change variables. I've used it for snowpack density. I've used it for surface temperatures and things like that. And in general, it's how this remotely sensed data is captured and stored. So I hope that answers the question.
Thank you, Richard. That's
okay. Yeah, really. I mean, I'm kind of at the end there. I've got the outputs. I've got my maps, and I've shown you some bits of code run through and how that works. So the next thing I'd say is go explore data. Go and get on R, download R, get RStudio. It's really that simple. Just those couple of steps. There's a bunch of tutorials. Some I've used myself over the years, and even to sort of refresh my brain for this tutorial. I recommend Robin Lovelace's. It's actually a really cool, good tutorial on a really nicely made website. And yeah, there's a bunch out there. So check them out. And yeah, thank you for listening. If you want to have a go yourself and follow along with my demo, you can come and get this video when it's uploaded to our Vimeo, and you can grab my code that I've literally just shown there in R as is with some comments. You can grab it off my GitHub. I've uploaded a gist, so you can run through run as I did, and maybe get a feel for like how those commands are working and what they're doing in what time, if it was unclear in any way, because I know things can be a bit odd on a webinar for that sort of thing. And yeah, lastly, any questions? Yeah.
Thank you so much for that run through, Richard. Quite the introduction, definitely. A lot went over my head, certainly, but I hope everyone got to follow. There's a few questions that have come in, so thank you so much again for the presentation, and
Sure, no worries.
some comments there on well done, and thank you so much, very valuable, which is great. So just a question, obviously you've touched already on the fact that you'll be sharing the code that you've exampled today, so obviously hopefully that answers some of the questions that have already come in. And also
on top of that one, I'll be sharing the code on my GitHub. As a simple gist, it's published and public, but in the code I've put comments of where the data's from, so I'm not actually sharing the data source because they're from proprietary websites, not proprietary, but they're from third-party websites. So you can go in and grab the link out my comment and go and download it yourself. And if there's any agreements to sign up to, then you can do that how you see fit. But you should be able to get the data sources that we played with today as well.
And which one of those data sets were open data? Can you sort of?
I think it's all open data. I think the Office for National Statistics produce both the boundary data, so that local area district data, and they also produce I think the census data is from the census. I think that might be distributed by the ONS. So yeah, that's available. That was only released actually on the 28th of June because it's the 2021 census data, sort of quickly formatted. So there's some cool stuff out there that not many people have produced maps on yet. So it's it's worth getting.
How dare they?
You might be able to get there first and create a nice population map if.
Good one. Yeah. Fabulous. Well, I'm going to start at the top from the questions otherwise, but yeah, as we've mentioned, you'll be able to get the slides that you've seen today, so you'll get all the content that were on the slides. You'll be able to get a re-record, you'll be able to have a link of the recording of today's session, so you'll be able to watch it back, or follow the code again, and obviously follow Richard's comments there, or advice, and yeah, and we'll share the links there as well that you've shared there, Richard, so thank you so much. One of our attendees has R Studio as part of Anaconda. Is that okay, or should it be installed as a standalone?
No, you should be able to go and get started. I think it's probably Anaconda's just been used probably to save that program down onto your laptop or your whatever machine you're using. So you should be able to just get into R Studio, and I imagine if that's been done as well, R will have been sorted by Anaconda as well. It's quite good like that, so you won't have to worry about your R version either. Versioning isn't quite as confusing as it can get on Python with R. I kind of alluded to it earlier, so you don't have to set up your virtual environments and work out what version of Python you're on and how it's going to run with the package you want or the library you want to use in Python. R kind of does that all for you. Don't have to worry. So I should expect it to be fine.
Fabulous. Thank you. Keep those questions coming while we're going through these, but we'll try and get through as many as we can. What do you reckon are the advantages or disadvantages of R versus Python in terms of power, flexibility, ease of learning? It's quite a big question, but I guess quite a relevant one for everyone.
Yeah. I won't lie. I won't be an expert on one versus the other. I think it's kind of horses for courses. I think if you're developing production code, and you want to take your Python code and you're going to put it straight into an application ready for it, sort of ready for some kind of engineering project, then totally go with Python. But if you're looking to get stuck in quickly and do some data analysis, then R is more than sufficient. And actually it is, I've been shocked at how much data it can take, and I'm talking sort of hundreds of thousands of rows up into the millions without suffering at all. And so it's not going to suffer with a sort of a big data problem. I don't imagine. There is some trade-offs, I think, actually, because I think R, as I say, is this statistical analysis package with some really nice visualization options and packages that to do whatever kind of visualization you want. But Python's got some really good machine learning packages, and when you know what you want to visualize, it's got some good visualization stuff as well. So if you want to get into sort of the machine learning space and run some of those sort of algorithms and bits and pieces like that, then yeah, maybe Python's right for you. I think one of the most important things about choosing the language you're going to start to do data analysis in is there's quite a few sort of prerequisites really, and what do the people you work with commonly use? You know, who are you going to be able to bound your ideas off and go, so what do my colleagues use? Do they use R? Cool, then let's get into it and I'll learn that. Do they mainly use Python? That might be more appropriate if you're building a product and that's what you've got surrounding you. And also what kind of, as I say, I alluded to earlier, like the problems you're trying to solve are is better suited to this statistical learning, and it's got, you know, the vast array of packages and libraries for statistics and analysis. Whereas yeah, Python could be a better choice for machine learning and big applications. Python also integrates really well with the web, whereas R doesn't necessarily do that from scratch. So you know, Python, as I say, might be more production ready and web deployable. Yeah, and then again, like how important the charts and graphs is another question in my mind when I think of the language. If I want to get some good charts and maps and graphs up, then I'm probably going to go straight to R, because I know that I've got the sort of extensibility to change that layout as I like, edit every variable of a map, and it's going to be a repeatable script that I've made, so I can use it again if I just change out the data set. Yeah, one thing I didn't show is I could have just changed that Wales data set to the UK, and it would have just spun up instantly. All that would have had to change the data set. I can show that if you think it's interesting. I don't know, maybe shout in some way if you want to see that quickly. But yeah, sorry, that's my answer. I hope it wasn't too bimbly.
That was great. Thank you so much. If there's follow-on questions, again, fire them into the question section. And just because you have just touched on that, there was a question that Mark uses pandas to clean up some of the land registry data. Does R handle large data sets? Of course, you've sort of touched on that, but do you want to just confirm?
Yeah. So I should imagine so. Yeah, I could imagine so. I've used it a million rows, and it hasn't struggled under me. I guess the important thing is R is probably going to be as efficient as your machine, you know. So if you're on a good laptop, it's probably going to do quite well. The same is clean. Yeah, the same is for Python as well. You know, if you're running Python locally, then it's going to use the machine capability that it's got. If you pop these on some VM in the cloud and run it at really high spec, then they're probably both going to do pretty well. But I've not got R all bunged up and stuck with data. So yeah, I'd imagine so.
Mm-hmm. And does R work? It's always weird. It is quite. Who came up with the name R? That's just so confusing. Well, just have a letter.
It's actually comes from S. So it used to be called S because S was a statistical language and it was for statistics. And then they just went to R. So there we are.
Interesting concept to just go with a one-letter name, but fair enough. So does R work well with PostGIS or PostGIS as
That's a good question. I don't actually know. I think there is no doubt integration outputs and inputs from PostGIS data sets, or Postgres as a database, PostGIS as the extension. So yeah, I haven't done it myself, but I would imagine so.
Great. Thank you. I mean, if you do experience it, let us know. Give us some feedback, or we might be able to try it with you. Yeah. Cool. We might be able to test it with you. Big learning curve for us too. Great. Can you use OSGB coordinates, or do you have to apply transformation to latitude, longitude kind of data?
No, so it can work in. You can take the spatial coordinate system that your data sits in. I think if it's not coming in sort of that long, then it's not gonna. I mean, obviously it projected there in 3857 in what I was showing, because we're talking about, you know, Slippy maps based on that common coordinate system. So you may have to add some extra flags to say the CRS I'm in is 27700 or something like that. So, but yeah, it works in a bunch of coordinate systems.
Yeah. Okay. Very good. And then also, can you advise on where's a good place to look for UK mapping data? quite
That's a good question. Yeah, I mean, there's a huge amount of UK mapping data that's out there, and there's open source if that's what you're looking for. If you remember, you know, we got some links to the land registry, as you know, and you can get some cool land registry data for a period of time. If not, then the OS has the data hub. I've got to plug the data hub. It's a really nice really nice platform for getting some open data from the OS. But you know, I want to be source agnostic. So there's OpenStreetMap. OpenStreetMap's good for the world, not just the UK. But if you're looking for some specific UK data, data.gov has a bunch on their portal. You can just search and search. You can set the data types you're only looking for spatial data as well. I quite like that. And then more specifically, if you know kind of the department or area you're looking for data, there's DEFRA. And there's the ONS has got statistical data, like I said, that's open on there. I think they call it the Open Geography portal. So there's a bunch out there actually. Maybe I'm just like whittering on. I could go for a while. But there's a good repository out there with like all the open data around the world. And I can link that if you're interested at some point. And that has a fairly up-to-date sort of UK heading, and then all the UK open data. And then it'll go on to another place in the world and the open data for there. But it's a good little repo of data sources. So I'll link that if people are interested.
Thank you very much, Richard. The other question is, I think there were a couple that came in around TMAP. So let's go to those. So is TMAP a good one for anyone experienced in R but who is new to GIS?
Yeah, I think so, because I think that quick thematic mapping option is like really neat to get in, and then you might instantly get that quick thematic map app like I did and go, oh, that doesn't look quite right, and then explore the package in Google or in the documentation and look for a bunch of attributes that you can start to chain together like I did with the little plus commands, and get something really neat quite quickly. It didn't take me long to go from a basic quick thematic map to quite a different color scale that I found. And Color Brewer changed the north arrow so it wasn't white and black, it was just a black plain north arrow. Alter the size of my title, bits and pieces like that. I think it's quite an intuitive package. There are others out there, but TMAP seems to be the pick of the choice at the moment. There's Ggplot 2. There's one called Ceramics. There's a few out there, but the two contenders here are TMAP and Ggplot. So if one doesn't do one that something that you want, then check out Ggplot. But yeah, I think TMAP's the most intuitive that I've worked with.
Okay, great. And could you highlight what the advantages of TMAP are over using the leaflet package directly? Sorry, big question.
Well, I think maybe that's a little bit misunderstood, because the leaflet is just a web map library. The good thing about TMAP is it gives you the option to go from those static plots to view plot, where it just pops that thematic mapping that it's done onto a leaflet web map environment. You can't use leaflet to style, like change the styling in R. You can make your maps in leaflet, but that's separate. You're doing that through JavaScript packages, completely different environment, completely different language. So the good thing about TMAP is it makes leaflet accessible to you straight away by just literally changing a mode, and it will sort that out for you and throw up a HTML page that you can keep and save. And so, yeah, they're slightly different things, but I hope that answers that question.
Thank you so much, Richard. I'm just conscious of time, of course, but just before I just raise one more question, obviously, if you have any further now, please do fire them into the question section. You, of course, have Richard's direct details there, but you can also email events@geovation.uk if you have any further questions. Of course, if you have some time to digest it, if you've gone back into the recording at a later stage and sort of wanted to play together, or for any other purposes that you feel like you want to reach out and sort of, process your thoughts.
Yeah, I didn't actually put my OS email there. So, but yeah, it's quite intuitive. It's just richard.hargreaves@os.uk. Yeah.
Yes, correct.
How can you tell I'm fresh when I don't even have my email showing?
No, that's okay. If you want to obviously just email events@geovation.uk, then we can make sure I connect you to Richard. That's no problem at all. Of course, we're also both on Slack, so if you are a Geovation member, then feel free to reach out to Richard directly there. I have shared with you sort of a survey, just a little feedback survey. It only takes about 3 to 4 minutes to complete. We always value obviously understanding how useful you found the session, but also especially what you might like to see more of. It's really important to me as the events manager at Geovation that we run these events that are relevant to you guys in the community or generally in the industry. I want to make sure that I understand what your blockages and your thought processes are, so I can make sure I can either obviously connect you with the right experts like Richard here, or find you those so that you don't have to. So please make sure that you let us know what you'd like to see more of in the event space in our program, so that we can make sure it's most relevant to you and your needs. So please do take those 3 or 4 minutes to complete that. We hugely appreciate it. Yeah, as I said, I always get a follow-on email from us, of course, with all the resources that we've mentioned today. And speaking of resources, before we do go today, Richard, would you mind sharing with us just sort of how everyone can sort of access the code that you kindly are offering?
Yeah, of course. So I can actually
on GitHub, just because I might, it might be that not everyone is hugely familiar with GitHub or isn't quite a bit sort of, able to navigate.
Yeah, of course. So the Vimeo has probably been published before, so you can go through my presentation and you can just find it on Vimeo. This will give you all the cool Geovation stuff we got going.
Yes, great.
and then GitHub. It's literally this simple. It's just a link. It's on my presentation. I assume people are going to get access to the presentation.
Yes, there is.
Yeah, cool. And then you just click on this link, and it will take you to the code straight away. It's there. You can download it. It's public, so you don't have to be a member. You don't have to be a user of GitHub. You can just download it as zip if you want, or you can click on raw even and just can Command A and download it quite quickly.
Amazing. Wonderful. Well, I will leave you everyone to go and enjoy the rest of your day and afternoon. Thank you so much, Richard, for walking us through this introduction to R. Very, very useful. And thanks everyone for joining. We don't take it for granted. We always appreciate when you join in and when you get connected and you engage. So please come back. We do have a session on Flutter as well next week on the 10th of August. So if you are interested in understanding a bit more about that, then we'd love to have you there. Dave will walk you through that. But other than that, I hope that you're going to stay healthy, you stay well and happy. Hopefully the sun will come back, sort of. And thank you so much for joining, taking the time, and we'll see you all shortly and soon. Take care.
Cheers. Thank you.
Thanks. Bye.
Bye.